In this video, we're going to program in an inverse hypergeometric probability function or program for the TI-84. Okay, so we're going to start by going to Program, going to create a new one, and I'm going to call this one INV HGO. HGEO. Inverse hypergeometric. All right, so first of all, we have to have it enter in the defining parameters. So we're going to variables, not variables, we're going to go to Program, Input, Output, Display, put it in alpha lock, quote. The first thing we're going to have it put in is the population size. POPULATION. Size. Quote. And I'm going to call the population size T and reserve the letter N for the sample size. So we're going to program, we're going to go to IO and prompt it for alpha T, the total in the population. Total of everything. Now we're going to prompt it for the, have the user put in the number of successes in the population. So again, we need to give them some idea what they're putting in. So we're going to go to Display, Successes, oops. In another display, another alpha lock, population. Okay, that's the number of success, and we're going to prompt it for success of the population. We usually call that M, so we'll use that letter here, M. Okay, while I'm at it here, let me go ahead and make up my slides while I'm at it. So there's our first set of inputs, and maybe put a little picture board around that. Okay, now let's keep going here. Okay, now the next thing we need to do is input the sample size. So let's go to that next. Program, IO, Display, Sample Size. Space is there. S-I-Z-E. Notice the space was the 0 key, right? Sample size, and then we'll have it prompt for N. Okay, so we have that in there. Next, we want to prompt it for the cumulative probability. So this will finish all of our inputs. Display, alpha lock, cumulative probability. TIVE. We're going to need a new line for probability. Display. Another quote probability. Let's probability P R O D L I T Y. So there's probability. And we'll do another prompt. So program IO number 2 prompt for, let's see, the cumulative probability we're going to call C. So we'll let that be C. All right, so now we got all of our things input. Now our first guess for our value of A is going to be given by an inverse normal. So so we go to distribution, and let's go to inverse norm. And the cumulative probability is C. The mean is N times P. P is M divided by the total. That would be capital N normally, but it's T here. Now this is a little more complicated, so let's look back. We'll look back at this formula. So keep track of what we're trying to put in. Here it is. Okay, it's this formula right over here. Okay, so we want to put in the square root of this one right here. Capital N is going to be T. Another parentheses, T minus N divided by parentheses T minus 1, close parentheses, times N times M divided by T, capital N's or T's, times parentheses 1 minus M over capital N is a T. Close that fraction, close that, and close the square root. Okay. I believe that's what I want there, and we want to take that and store it as A. So that's our initial guess for A. Now, we want to knock A down some to a whole number, or at least an integer. So math number, go to the integer part, and take A. So the integer, alpha A. Alright, that's fine. We'll get that, replace it. Integer part of A. And store that as A. And then I want to subtract, what I want to do now for A, finally, for my starting value, is I want to do the minimum, the maximum. Let's go here. Math number 7, maximum, of either the A that we have, minus 1, or 0, whichever one of those is bigger. So we don't want to go below 0. And we're going to store that as A. So there's our first value for A. Now, we're going to have to do a cumulative probability, where we're going to have to make a matrix to store this. So let's do that next. Our matrix is going to have 3 different x values, and then it's going to have the x value, the proportion, and the cumulative probability. So it's going to be a 3 by 3 matrix. So we need to set up a matrix with that dimension. So we'll go braces 3, comma 3, and we'll store that as in the matrix. Go to math and go dimension of matrix. We can just use the A, I guess. You could use any of them, but let's say we're going to use A. So that'll set up A with the right dimension as 3 by 3. Okay, now let's see what else we got to do next. We've got to run through a loop here. And, well, the first thing I can do, I can actually set up all the x values right now. So let's go ahead and do that. So we're going to take A and store it in our matrix in the first row, first column. And then we want A divided by the sample size, which is n, which will be the proportion in the sample. Store that in our matrix, in the matrix A, in the first row, second column. Now we want to take A plus 1, store that in our matrix, in the second row, first column. Take the A plus 1 divided by the sample size n, store that in the matrix of, that's the second row, second column. And then we want to take A plus 2, store that in our matrix. And we're going to put that in our third row, first column. And the corresponding proportion is A plus 2. We want to divide, oops, that didn't work out. Parentheses, A plus 2 divided by n, and store that in our matrix. Okay. And that's going to go in third row, second column. So we've got everything but the last column fixed up of our matrix. Now, we have to do a cumulative probability for that last column. So that's going to be a little tricky for the first one. So we're going to run a for loop for that, kind of like we did when we were doing this cumulative probability before. So we're going to run a for loop. We just need a counting variable. Let's just use k. For k going from 0 up to whatever a is, we're going to figure out the probabilities. Let me insert something first. Let's initialize 0 in some letter that we haven't used yet. Y is fine. Okay. And what we're going to do is find the probability of that particular k. Now the probabilities, if you remember on a hypergeometric, are the m, and then you choose whatever x is, which in this case is is k. Okay. Times. Then you do parentheses n, capital N, which is t in our this version. So the total minus. So this was the way the m choose k is the number of ways of getting the success, and then we do t minus m, and then we want to choose then that's the number of failures, and from that we want to choose the n minus k failures in the sample. So t minus m is the failures in the population, n minus k is in the sample. Then we want to take that and divide it by the total number in the population, choose the total number in the sample, n. And that's the probability of that particular k value. We want to take that and add it to our y that we have and store our answer back in y. And then we run this through the for loop all the way up from 0 to a. And this is essentially does the summation for us. So then we go program 7 to end it. So now the value of y is our cumulative probability for A. So we want to take y and store it in our matrix. Now it's matrix A, and we want to store it in the first row, third column. Okay, and then, okay, so that should get that in there. Now what we want to do is we just have to take that y and add one more probability to get the next one. So we want to take the y that we have and add that to that one more probability. So the one more probability is m choose A plus 1, so parentheses A plus 1 times parentheses total minus m choose sample size n minus parentheses A plus 1, close parentheses for the A plus 1, close the parentheses for the n minus, close parentheses for the choose, divide that by parentheses total choose n, and take all of that and store that back in y. Well, yeah, let's store it back in y. And then we want to take that y and store it in our matrix in the second row, third column. All right, we're almost there. Now we take that y and add one more probability, the probability that it's A plus 2. So this is going to be very similar to that. We're going to start with m choose parentheses A plus 2 close close times parentheses total minus m choose. Okay, what are we choosing? We're choosing this n minus parentheses A plus 2. Close the A plus 2, close the n minus, close the choose. Divide by total n choose r, and we're choosing from that n. Close, store that back in y. That y is our last cumulative value, so take that y, store that in our matrix. Okay, this is all to get it. 3, comma, third row, third column. Okay, our matrix should be set up. So let's start give our display on the end. So we're going to display what do we want to display? Let's display something to tell us what's going on. So let's do an alpha lock quote. Actually, what I do to do a lock quote parentheses x comma p hat p dash alpha p dash hat alpha lock HAT which is our proportion, and then take the alpha lock off, comma, and then CDF of x, alpha on CDF alpha off of x, close parentheses, quote, So display that, and now display our matrix. All right, we're done. Okay, quit. That should save it. Now let's hope this worked right because there's a lot of typing there. Program, and let's run inverse hypergeometric. And let's say we have a population size of 200, and there are 45 successes in that population. We're going to draw a sample of size 15, and we want to see when the cumulative probability first reaches 0.8. Now, unfortunately, it doesn't scroll over, so you need to know, hopefully, matrix A, and from there we can scroll over, and we see it first reaches 0.8. Actually, at this top, that's too small. The last one is the best, is where it actually crosses over. So at first it reaches 0.8 at 5, and these are the proportions here. Now we could also go through here, for example, and temporarily set it at, like 4 decimal places or something like that, and then look at our matrix. And now we have just the 4 decimal places, or even if we want to actually see more of it, we may be able to get what we need by like only 2 decimal places. So you might want to go to mode, for example, temporarily. I like to leave it on float, but we might want to see 2 decimal places in our matrix. And then when we look at our matrix A, now we can see what we want there. So, of course, our X's, it's also showing 2 decimal places here, which those are just 3, 4, and 5 exactly. But you can see those probabilities sort of rounded off. That's probably going to be good enough for us. So we might do that. What we might want to do, we might want to go back here on this program and, no, not there. We want to actually go back to editing it. And we might want to go back in here and at least tell people where the answer is. So if they want to pull up that A, actually, let's see. We might want to say, we might want to insert another line here that says display, and then put in some quotes matrix A, so they know that the answer is actually in matrix. I didn't do that. Alpha quote like that. So now when I run it, it'll actually say A, and then do that, so then you can go back and see the A. So you can tweak this a little bit if you want to force it to round off or whatever, but that works. That works the problem there.